and healthy and ready to learn new things. So my name is Palak Patel. I am working in the Mahatma Gandhi Institute of Technical Education and Research Center in Navsari in Civil Engineering Department. I am going to teach you the subject is Design of Structure. Subject code is 3150612. Subject are in PE third year, SEM 5th. So in this chapter, we are going to learn bond and encourage and development length and shear reinforcement design. So shall we start? This lecture we have a content like bond, development length, shear reinforcement and design of shear reinforcement. First topic is bond. So what is bond? Bond is the grip of reinforcement and concrete due to adhesion and bearing is termed as bond. Grip of reinforcement and concrete. Look at here. This is your concrete and this is your reinforcement. Okay. If is a bonding between reinforcement and concrete is called bond. Okay. Simple definition. Simple definition. The connection between the concrete and the reinforcement is called bond. Okay. These are some bond stresses which are given from the IS 456-2000 page number 43. Bond stresses definition is shear force acting per unit surface area of the bar. The shear force acting per unit surface area of the bar in the direction of force is known as bond stresses. Okay, so these are some concrete grades M20, M25, M30, M35 and M50 and above. So by this table we can found bond stresses. Design bond stresses which is denoted by tau BD and unit is Newton per mm square. Okay. This table is given in the IS 456-2000 page number 43. Okay. Development length. What is development length? To transfer the design force from steel to concrete and vice versa. To transfer the design force from steel to concrete and vice versa, the reinforcement is anchored or amended in a concrete for some length. What is encouraged and amended? Amended means extra length. Extra. Simple word. Reinforcement is extra in concrete for some length. A length of reinforcement amended in a concrete so that it can develop the bond stresses is termed as development length. Okay, development length is denoted by LD. We can find development length by this equation phi into sigma s upon 4 into tau BD. Okay, here LD is equal to development length, tau BD is equal to design bond stress in concrete. How can you find tau BD? By the IS code 456-1000 page number 43. Okay. Sigma s can be found by a 0.87 Fy. What is sigma s? Sigma s is equal to traces in bar. Okay, and last one is phi is equal to diameter of bar. Okay, then after development length we have the one more definition is bundle bar. So what is bundle bar? Bundle bar means you can see here is a cross section of a beam and we provide a reinforcement like this. Okay. These are the simple format which we provided. But in a bundle bar cases, the reinforcement is provided like this. So this type of reinforcement provided is called bundle bar. Bundle of bars. Imagine you have one pencil here, okay, one pencil here, and you have four pencil. So what we do? The one pencil we call a pencil, but when we tied up this four pencil in one row by one row, so this type of four pencils by a tied up by a rope, we call this as a bundle. Okay, bundle of pencil. So same phenomena is here. If we tied up a four reinforcement at a one point, four, two or three reinforcement at a one point, we call this as a bundle bar. Okay, bundle bar is used for the increased development length. So how we increase development length? This is 10% for the 2 bar in contact, 20% for 3 bars in contact, 33% for 4 bar in contact. Okay, reinforcement. So what is anchoring? Anchoring reinforcement with extra reinforcement. What is extra reinforcement? Bands or hook, we call this anchorage reinforcement. The anchorage value of band shall be taken as 4 times the diameter of bar for each 45 band, subjected to maximum 60 times the diameter of bar. So this anchoring means length will be increased. If we provide a reinforcement like this, okay, instead of this, so this length will be increased. So this extra length we call as anchoring. Okay, so these are the four times the diameter of bar for each 45-degree band, subjected to maximum of 60 times the diameter of bar. Okay, then after hook, the anchorage value of standard U hook shall be 60 times the diameter of bar. Anchorage value means 60 times must be what? Anchorage value is 60 into 5. So this is called anchorage length. Same time for the band we have 4 into 5. This is called an anchorage length. Okay. So why we provide an anchorage length? So deformed bar may be used without an anchorage, provided the development length required is satisfied. Means by anchoraging we can satisfy the development length. What is by the development length? By the development length we can increase a bond between concrete and reinforcement. Okay, so why we provide a hook or band? We provide a hook or band for the increased development length, but by a development length we can increase a bonding between concrete and steel. You can see how all the things are connected with each other. Okay, so this for this we require the hook in the reinforcement. After bar in the compression, so anchorage length straight bar in compression shall be equal to the development length of bar in compression. So in the compression we provide a straight bar, almost last hook will be provided, okay, but no bend up are here. In the compression zone no bend up are here, so only straight bar is there. Okay, encouraging bar ends here. What is a bar ends? Incline bar. The development length shall be bar in tension shall be measured as a tension zone from the end of sloping or inclined portion of the bar. The compression zone from the mid depth of the beam. The development length can be calculated in a tension zone from the end of sloping or inclined portion of the bar. In the compression zone, incline bar, we can find it from the mid depth of beam. The stirrups in a beam are tied in column, complete development level, encourage cell beating. Are end bend through the angle is 90-degree round bar of at least one diameter and continue beyond the end of the curve. Its length is 5. When the bar is bent through the angle 130, bar is bent through the angle 180, development length shall be 4 degree beyond the end of. So what is the angle? Here is a reinforcement, and for the outer surface we call this as a, this is a stirrups. Okay. For the bend through the angle at least 90-degree round. What is 90-degree? I should change the pen color. Okay, dear students. If your reinforcement look like this, and one portion is going through. Okay, look at here. At the end, it's the end of the stirrups. You can see like this. Okay, and one more stirrups is like this. One end is look like this, and second end is look like this. At that time, at that time, this angle will be 90. Same condition here, 90-degree angle. So why this 90-degree angle? The length at least 88.5. Okay. When the bar, so the angle is 135. When will be bar will be angle will be 135. You can see here is your stirrups. There is the reinforcement. By 135 means your stirrups end is look like this. This angle is 135. So bend through angle 135, your development length is 6 into 5. 5 is the diameter of bar. Okay. And the bar bent to the angle 180. This is 135. So how you look at 180? Like this. Like this. This type of 180 angle, length shall be 4 5. Understood? Understood? Simple, simple. It's a simple and between the end, okay? Between the end. Wait a second, students. Yeah. Is IS 456 2000, we have a recommended additional anchorage length equal to L0. Ensure anchorage bond stress is within the maximum limit such that, so these are the equation to find out development length. L0 is called anchorage length. So by this equation you can check there is a development length and anchorage length are both are required condition. Okay, so these are the check equation. LD laser equal to M1 upon V plus L0. Okay, shall we start here? For the example 1, we have to find a development length. We have to calculate development length for the 20 diameter and Fe415 grade steel bar. This bar in a compression concrete grade is M20. Yeah. Okay, here is the given data. Diameter 20 mm, FY415, FCK20, and bar in compression. So we can find out the development length. We have equation for the development length is equal to phi into sigma s on 4 into tau PD. Okay, we have to find out sigma s and tau PD. Phi is what is 20 mm. Tau BD and sigma s we have to find out. So sigma s is equal to 0.87 into Fy. This equation we discussed earlier. 0.87 into 415. Fy is 415 grade of steel. So by the sigma s equation we got a value 361.05 Newton per mm square. Now designed bond stress tau PD. Tau BD is 1.2. How can you find out tau BD? We can find out tau BD from the IS code. From the IS code. Just give me some 5 to 10 minutes for find out IS code. Indian standard I45000. For find that 20. So tau BD is 1.2. Tau BD is 1.2 sigma 1.2 Newton per mm square. But we have a concrete bar is HYST bar and enough steel in a compression zone. So increase the tau BD value by 60% for the HYST bar and 25% for a compression. Compression means your enforcement in a compression. For the deform bar confirming this will be increased by 60%. Increased by 60%. For the bar in compression, the value of bond stresses in tension shall be increased by 25. To value this table is given for the only for the tension. So by this table we can find out this two value by a 60% by a 25%. Okay, so we have to added 60% in the tension zone. અત્યારે નહીં this table we have a value is a 1.2 for the tension zone, but we have a deform bar. Deform bar 415 grade steel, so your value will be increased by 60%. Okay, okay, understood. and as well as your bar in the compression zone. So this value will increase by 25%. Okay, that means look at here, you increase this value. So tau BD is 1.2, but is we have a HYST bar, so it's multiplied by 1.6. Okay, 1.6, as well as this bar in the compression zone, so multiply by 1.25. This value will be increasing 2.4 Newton per mm square. We have a two conditions here, both are fulfilled. If your reinforcement is not HYST bar, means your reinforcement grade is 250 mild steel, so that time we not, this value will not increase by 60%. Okay, and as well as if your reinforcement are in not a compression zone, reinforcement are in the tension zone, so value will not be increased by 25. So that time if your reinforcement is mild steel and in a tension zone, the design bond stress is 1.2. Okay, so we found the all value here. Put down this all value in this equation. LD is equal to 5 into sigma S upon 4 into tau BD. We got the value 5 is 20. Sigma S we found it 361.05, 361.05, 361.05. 4 into tau BD is 2.4. We got development length is 752.80. 752.80. Understood? Okay. So your example is completed. This is the development length. First example is completed. So we start a second example here. Start a second example here. In the second example, we have a column of multi-story building is reinforced with 25 mm diameter bar of Fe415 grade and M25 concrete mix. Calculate the lap length required and sketch details. Lap length means your reinforcement look like this and this is the end, but your structure going further that time at this type of reinforcement. This length is called lap length. Okay, so we have to find out diameter of bar, Fe415 grade steel, FCK 25 Newton per mm square. Okay, and then after column bar means compression. Column is always in a compression. Remember this. Beam has two zone. Upper is tension, lower is compression. We discussed this in the single beam design. Okay, but column always in compression. Always. Okay, if your column is in a vertical line, that time is always in a compression. Or if your column has some angle, that time we can found a tension and compression zone. But if your column is a straight vertical line, we have column compression. Okay, and sigma S 0.87 into Fy. So what is Fy? 415 grade. So sigma S is equal to 361.05 Newton per mm square. Okay, here is the same method we have to follow to find the lap length. And design bond stress is 1.4 Newton per mm square. Why this? So let's check in the IS code. Okay, in this table we can find a design bond stress tau BD Newton per mm square, as well as we have a concrete grade M25, concrete grade M25, So what is the value of design bond stress is 1.4. Simple, simple 1.4. But 1.4 is for what? It's 1.4 is for the tension. When your reinforcement is tension, we have the M25 grade concrete. We have design bond stress is 1.4. Okay, but we used a deformed bar, HYST bar, IA FY 415 grade bar. Okay, deformed bar. So at this condition, your 1.4 value will be increased by a 60%. Will be increased by 60%, as well as this reinforcement in the column. So your bar is in the compression, so bond stress is increased by 25%. Okay, 1.4 multiplied by 1.6 into 1.25, so tau 8 Newton per mm square. Okay, so put the all value in LD equation. Phi is to sigma s upon 4 into tau BD. So phi is 25, sigma s is 361.05, divide by 4 into 2.8 into 2.8. So development length is 805 805.91 mm. These are the development length. And here is a look at here. It's the figure here. It's your column. It's your column. Okay. And you can see here is a reinforcement. It's a reinforcement. And these are some lateral ties here. And you can see its lap length is 806 mm. Okay. So these are the development length 806 mm. So your second example is completed. Third example, I give it you for the practice. Simply supported reinforced concrete beam size is 300 by 500 mm. Effective is reinforced with 4 bar and 60 mm diameter and Fe415. Determine anchorage length of bar at a simply supported end if is subjected to factor shear force 350 kN. At the center of 30 mm wide masonry wall, the concrete mix of grade is M20 is to be used. Okay, these are the third example. So we start for the calculation. Okay, here is you can see there is a simply supported concrete beam which size is 300 by 500 mm, and here we have a 4 bars is 60 mm diameter, grade is Fe415. What we have determined the anchorage length means the development length of the bar. Okay, and one more thing, we have a simply subjected to factor shear force 350 kN. Our beam is subjected to factor shear force 350 kN at the center of 300 mm wide masonry wall. At a 300 mm wide masonry wall. Okay. So here is given data is 300 mm. Is 300 mm width of beam, depth 500 mm, area of steel in a tension zone 4 into pi by 4 into 60 whole square, 4 into pi by 4 into 60 whole square. We need the area ET value, FCK 20 Newton per mm square and Fy 415 Newton per mm square. These are the given data. Okay. Design bone stress for M20 concrete. The tension zone 1.2 Newton per meter square. How we find for the M20 concrete? Same table here. Same table here. You have to follow same table. Okay. 20 grade of concrete. So design bone stress is 1.2. Increase the value by 60% because HYSD bar 415 grade of steel. So 60% HYSD bar. But your bar in a tension zone. Your bar in a tension zone. So increase this value by a 25% is not included here. It's not add here. So in this example, tau BD is equal to 1.2 into 1.6. Okay, because your bar in a tension zone only 60% value will be increased. 60% increasing for the HYSD bar. Okay, so tau BD is equal to 1.92 Newton per square. Same value for the sigma S 0.87 into Fy. Fy is 415. So sigma S is equal to 361.05 Newton per mm square. Okay. LD development length is equal to phi into sigma S upon 4 into tau BD. 4 into tau BD. So we can find all the values. Sigma S is 60 mm diameter. Sigma S is 361.05. 4 and tau BD 1.92. LD is 752.20 mm. 752.20 mm. Okay. Then after we have a notes here for the encouraged bond stress is not exceed a design value. The following condition at the simply supported end of the beam should be satisfied. So for the encouraged bond stress, we have to satisfy this condition. LD lesser equal to 1.3 M1 upon V plus L0. LD we find out. L0 is encouraged length. So we have to find out encouraged length. So M1, how we find M1? For the find M1, we need XU. XU means depth of neuter axis. XU equation is 0.87 Fy AST divided by 0.36 FCK into B. 0.87 Fy 415 area of steel in the tension zone. Four numbers of bar of 16 mm diameter. By this detail we can find the area of steel in the tension zone. This value is 804.36 FCK 20 width 300. So XU is 134.39 mm. 134.39 mm. And after XU max is equal to 0.48 D. 0.48 D. So 0.48 into 500. So 250 mm. So by this value XU max is maximum. XU max is more than XU. So the section is under reinforced section by this condition. So we have to use this equation for the find the M1. M1 is equal to 0.87 Fy AST into D into 1 minus Fy capital AST upon FCKB into D. FCKB into D. So Fy is 415, capital AST is 804, D is equal to 500 into 1 minus Fy 415, capital AST 804, FCK 20, B and D is 300 and 500. So by this equation we can find out M1 129 kilonewton into meter. 129 kilonewton meter. This is the M1 moment. So we can find this value LD lesser equal to 1.3 M1 upon V plus L0. So LD is 752.2. LD is 752.2. 1.3. M1 we find out 129 into 10 raised to 6. V is 350. 350 is what is shear force. V is shear force. So we have to given data shear force is 350 kilonewton. So by the Newton 350 into 10 raised to 3, we have to find out L0. After the solve this example, we found LU is less or equal to 273.06. Okay. By this L0 minimum, we need L0 minimum, anchorage length, minimum length is LD by 3 minus width of support by 2. LD is 752.2 by 3 minus 300 by 2. We got the value. So we provide L0 is 273.0 mm. 273.0 mm. Okay. These are the minimum L0, minimum anchorage length, but we provide 273.0 mm. So look at here, here is a figure. You can see here is a bar. These are the anchorage length L0, 273 mm, cover 25 mm. Okay. So our third example is completed here. Example is completed. So in the next lecture, we start a shear reinforcement design. Okay. For the learning the shear reinforcement design, be prepared and meet soon.